Alright, so now on to the main portion of the code, which I've downloaded from MathWorks. The name of the file is called Carving a Dinosaur. I simply got it off the MathWorks website. It was uploaded by and created by Ben Tordoff there in January of 2010. And he also has a nice little, by Lauren Scher, a little blog about how the demo works. The original intent is the demo is used to find the volume of an object that's not uniformly shaped. But our purpose is simply to recreate a 2D object in 3 dimensions using this silhouette style space carving. So this one is fairly simple. You upload your program here under the directory space carving. It's got all the files. And then you need to upload, if you're using unique data, I simply renamed it. Here's the original data. As you can see, it's all labeled the same, VIFF dot, same numbering system, and it will accept PMM or JPEG files. But since it was far easier to change the name of the files than it is to change all the references, I simply went with the same naming convention. And as you can see, there are my pictures of my bags of coffee. It's kind of a weird shape. Fairly uniform, but there are dents and crinkles in it. So we'll see how this silhouette space carving takes it. So, simply put, we run the program and it immediately starts loading the images and getting to work. This is pretty memory intensive and takes a little while, so I'm going to pause the video. Okay, so we're back here with some of our figures. This program produces 8 figures in total, and we're going to walk through them one at a time. The first figure displays the 36 input images, which is the bag of coffee on our turntable, and at every 10 degrees I take another picture. Figure 2, close this. Figure 2 is one example of our first input image, and it's taking a silhouette of the image, so it detects if the particular pixel is more red than blue, it's going to make it a 1, and if it's more blue than red, it's going to make it a 0. 1's turned white, 0's turned to black, and it does a little bit of computing in between. If you have a blue in the middle, it doesn't automatically poke a hole through it. So we'll move on to figure 3. And once this comes up, it will be of our voxel array. Sorry for the blackout there, but the voxel array is computed based on the input images to begin with, and that's what we're going to carve away, one image at a time. Now, the blue prisms around represent the cameras and their location in space. So in space, we're going to carve away, hence the term space carving. If we move on to figure 4, it's going to show the single camera as it's applying the silhouette against the voxel array. Now, granted, it has really no depth information yet, so that's why it just looks long and just a coffee-shaped prism is all that is. But when we go around and we start adding more cuts to it, just like in Figure 5 with these 3 cameras, you're going to start to see as a result, it's actually going to start forming the bag of coffee. In Figure 6, after 36 carvings, you're going to get this basic image of our bag of coffee. Now, it also just Ben Tordoff has added a nice little algorithm to smooth it out and add a little refinement. So this is kind of the back end, and here's the front. There we go. There's the top of the bag. There's the bottom of the bag. I was laying it on its side. And it also adds some texture, even though it's a very rough texturing at best, of our bag of coffee. And that is simple space carving using silhouettes via MATLAB. Let's head back for a moment. Alright, now once we're done with the demo, let's evaluate our results here. As we know, a single view results in just a prism, since a 2D image cannot provide that depth information we talked about earlier. So the more images you take from the different viewpoints, that's where you get your depth from. I did see some problems. I originally tried to use this little knight figure in the lower left-hand corner. Now, he's got a lot of concavities that you're really not able to get and capture from taking the silhouette alone. Most of that information, like the cape and between his legs, behind his weapon, you're just not going to get that from taking the silhouette by itself. And it's going to leave an imperfect result, as you can see here, where all of that information has been filled in because that cape, as it goes wide, it covers up all of that internal detail. With the larger objects, like the bag of coffee there, it works a lot better because even though there are some concavities to it, for the most part, you get a good representation from the silhouettes. Let's look at some alternative techniques now. One of the biggest ones that I found was the statistical consistency check. This is Broadhurst and Chipola, excuse me for mispronouncing their names. They researched complex outdoor image sequences where they were using very large inputs. In this case, they used buildings, and they also used a fountain. The problem that they were having is when they tried to capture the data, a lot of data was lost when it came to the windows. And as you can see in some of the areas, the windows are just turned white. So what they decided to do is project the voxel's exterior boundary onto each of the input images and determine which of the pixels are inside the projected shape. They decided to see, all right, statistically, does it exist or does it not? If it doesn't reach a certain threshold, they throw it out. And of course, they decide the threshold of whether a voxel is going to whether the voxel is supposed to be in the image or not. Note, just with their approach, the window data for the most part is filled in, leaving a better representation. One of the other techniques that I looked into was using a handheld camera and a background image. Now, why this is unique is they hold on to the camera, and there's really no way to tell the calibration information unless you've got some sort of point that you can reference off of. What I used was the dots, and what Montenegro, Varvalo, and Velo decided to use was a pattern. The object to be captured, which in this case is a Tweety bird, is placed over that unique pattern, and as you can see in the lower left-hand corner, and as so long as their pattern is recognizable that by the software, you're able to extract your calibration information. If you already know how long each one of these lines are and where they're supposed to be from a set of input images that you've already taken of just the pattern, from then on out, you're going to be able to determine your angle, your skew, where your camera is in relationship to your pattern. Now, there is a slight problem that you do lose some data from the Tweety bird here when you try to recreate it, because the camera or the software is looking for the lines, and it has a tendency to carve away trying to look for those lines. So the next section we're going to look into is future applications and techniques. I can really see this being used as a very inexpensive 3D scanner. I can see a lot more virtual museums and walkthroughs, especially for potential homeowners that are looking to buy a house. If you live in Florida and you're wanting to buy a house in Colorado, it's far, far cheaper to have someone who is in Colorado walk through with a camera and use some software and build a 3D floor map for you to walk through virtually from your home in Florida. Another possible application I see is right now you can see Google Maps, and it's such a great application, and you can get a general idea when you go onto Street View mode, but it's really kind of a flat image that you're looking at. As these cars travel around different countries, you can easily build 3D maps based on your GPS data, and just knowing the general size of some buildings, you can completely recreate these buildings. Other future techniques I can see is using a UAV, in this case, a little helicopter with a GPS locator and a rangefinder to calibrate its onboard camera, and you can fly around and you can get 3D images of hillsides, of roadways, of different pathways of buildings. And since I am in the military, I see a lot of intelligence, surveillance, and reconnaissance capabilities coming out of this particular technique. In my conclusions, while using the silhouette space carving techniques is very simple, it has a lot of potential to lose a significant amount of data, and it has a tendency to drill holes through the object that you're trying to recreate. Other techniques use consistency checks and statistical comparisons to prevent that kind of data loss due to concavities and poor angles. And with that, here are my references, and I hope you enjoyed. Thank you.